Yes, see, students, it's a very good thing that you are completing the assignments. What I am finding, who have not completed the assignment, just see here. Before that, let me share the screen. Yes, could you able to see the screen now?
Yes, sir.
See here. Two have not submitted. It seems to be. Who are those two? One is Ismail. He's not in the chemistry now, but he was studying chemistry. And other is Ankita. But if I come to the submitted assignments, the list of those students, then I will find the name of the Ankita. She has submitted late, but she has submitted till now. Means Ankita's name is there both where in list of the submitted students and in the list of the not submitted student. Why it has happened? Because she has registered two times. Maybe two different email IDs she has used. Therefore, here she seems to be absent or not submitted. Now she is not present in today's lecture, but I suggest and expect from other students that they can communicate to Ankita that one of the her identity registration is to remove. I can help her for that removal, but she should contact. It is expectation. And this recording later on, whenever she will come across, then she has to do that improvement. It's expectation. Is it clear to all?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, students. We were discussing the pi bonding in the metal ligand complexes, and that pi bondings are of the two types. As like recently I got the answer. One is M to L kind of pi bonding, and other is L to M kind of the pi bonding. Now let me open the whiteboard. I'm sharing the screen so that directly you could able to see that the whiteboard. Okay, you can open it through the link also, and other directly here screen I am sharing, so you could able to see the screen. As a feedback, let me know. Could you able to see the screen?
Yes, sir.
Good. The M to L kind of pi bonding, about which regarding the molecular orbital levels, as energy levels, I had a discussion. But let me revise it very shortly, and then I want to complete the L to M kind of pi bonding. There we will end our today's discussion. What we have studied, the metal is with its own orbitals. Those interact with ligand group orbitals and they produce the molecular orbitals. Out of those molecular orbitals, I like to consider two orbitals, two sets. One is T2G and other is EG star. Let me label this. One is EG star and other is T2G. About this approach, what were we considering? The energy gap between these two energy levels, that's a T2G and EG star, was a delta O for our consideration. But now this delta O is going to change because of new kind of interaction, and that interaction is the pi interaction. And in that pi, especially it is the M to L pi kind of the interaction. Now I have to consider the second set of the orbitals which can interact. Those are the ligand orbitals. Now ligand orbitals, while considering sigma bonding, I told you those ligand orbitals are of low energy than that of the metal ion because of electronegativity, because of their fulfillment that I told. But here that logic is not perfectly applicable. It can vary. What can vary? Energy of ligand can vary. It depends upon the orbitals which we are considering from the ligands. If I have to focus on the metal to ligand bonding, metal to ligand pi interaction, just let me see, is anybody interested to join? Metal to ligand pi interaction, then from ligand, the orbitals are d orbitals, high energy level d orbitals. Listen carefully, high energy level d orbitals. Or orbitals can be anti-bonding p pi orbitals. Anti-bonding orbitals also are of the high energy. Means my highlight point here is the energy for orbitals from ligand will be high. Students, are you going to cope up the Discussion.
Yes, sir.
Yes. So from ligand, I want to consider the T2G orbitals which are of high energy than this corresponding the T2G orbitals from the metal. So these T2G orbitals from ligand, let me consider. If such two sets of orbitals are there, set I am considering from the point of symmetry. Symmetry sets of the orbitals are there, then those can produce a two further set. One will be the bonding, say the energy with which it decreases 1 dot, 2 dot, 3 dot, 4 dot, 5 dot example. Say with 5 dots that energy is decreased. Similarly here with 5 dots energy will decrease from low energy orbital, metal T2G orbital, metal T2G set. And increase will be from ligand T2G set, 1 level, 2, 3, 4 and 5. So here I have to represent the T2G orbitals. Let me represent it by the blue color. T2G, that's the 3 orbitals. Here also I represent it by blue color. These are the 3 T2G orbitals. Let me complete it, the interaction. So actually the T2G orbitals anti-bonding, but they are obtained from ligand also. These T2G orbitals are bonding, they are obtained from ligand and metal both. So everywhere ligand and metal interaction is certainly there. How can I label those orbitals? Their bonding orbital I can say as simply T2G, and anti-bonding orbital as T2G star, asterisk. Okay, T2G orbitals, T2G sets, their interaction we considered. But what about this EG star set? EG star, it is anti-bonding orbital obtained during the ligand and metal interaction, sigma bonding. But the sigma bonding already we have considered. Today we are talking about the pi bonding. And so pi bonding, only T2G orbital is going to run. T2G orbital is going to play the role. About that, the EG star orbital, we need not to talk more, or it will remain non-bonding. So that EG star orbital is a non-bonding in case of the pi bonding. Actually, EG star means anti-bonding orbital. But total MO diagram, if I have to consider sigma and pi bonding, then that EG star orbital I'll represent as it is without any change in the energy. Now I want delta O value, because delta O value is a very important term. That's a splitting parameter that decides the stability, that decides the electronic configuration. Too many aspects are there, those are related to the delta O value. How can I define the delta O value? Previously, delta O I was considering as energy gap between this T2G orbital and EG star. Now, which T2G orbital I should consider? Don't go on only name. This is a T2G orbital. It is also one of the T2G orbital, also T2G star. Out of those two, which orbitals shall I consider? So this T2G orbital and this T2G orbital, they are near. What I'm saying? This T2G orbital and this T2G orbital, they are near. If near the orbital is, more contribution it will be, more effect it will be. It's a relative aspect. So compared to upper T2G star orbital, this lower bonding T2G orbital is near to the previous T2G orbital present in sigma bonded metal ligand complex. If that orbital is near, more contribution, more weightage. So out of those two, which two? Number one case is bonding T2G orbital, and number two case anti-bonding T2G orbital. Out of those two, which orbital is near to this T2G orbital? This one. This is near. So this T2G orbital, bonding T2G orbital, I need to consider to explain this delta O. So energy gap, if I have to consider, then energy gap will be from that bonding T2G orbital. This will be the one of the energy level. And other energy level, of course, the EG star, it was as before. So it is other energy level. That's a EG star. So energy gap between these two, EG star and T2G. What is that energy gap now? Please help me. That energy gap is equal to, just complete. What is the new value of? The value of, what is that? Previously, delta. Yes, delta. It is O, octahedral complex only. Octahedral complex only. So delta O. Previously, delta O was this much. Only small value was there. Now, delta O is large. So delta O increases. I remember last time also I told delta O increases in case of metal to ligand pi bonding. Is this interaction and MO diagram for pi bonding clear to you? If not, then say no, I'll repeat.
Clear, sir.
Clear.
I want one more reply.
Yes.
One more reply. Okay. Now I remove that previous frame. Today I want to discuss ligand to metal pi bonding. And for ligand to metal pi bonding, we need to consider examples. Which examples I told you? Halide ligand means it can be chloride, it can be bromide, or it can be fluoride. Of course, iodide also may be there. X minus is a general representation. And if you see, these are the 17 group element. Those elements are relatively electronegative. Electronegative means they will have the tendency to attract the electron more towards itself, means they have already whatever their property electron that is shrink, that is there in the lower energy orbital. So because of their electronegativity aspect and because of filled orbitals, previously vacant orbitals were there, now orbitals are filled. Answer for my question, what will be the energy? Energy will be low or high? Yes, what will the energy? Energy for these ligand orbitals will be high than the metal orbitals or will be low? Orbitals are filled. When orbitals will be filled, if they are off, yes, that energy will be high or low? That's my question.
Low.
Right, low energy means electron will fill. Electron filling takes place from low energy orbital to the high energy orbital. High energy orbital means electron possibility is less unless excitation. Excitation is a additional thing. Naturally, low energy will be preferred by the electron, and electrons are filled, so certainly there will be low energy. Electronegativity, again the low energy. So first the conclusion that I want to tell you, energy for ligand orbitals will be less, will be low compared to energy for corresponding orbitals from the metal. Is this point clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now pay attention towards the MO diagram. As usual, I want to consider orbitals in the complex, considering sigma bonding. And one of the orbital that I considered is a T2G orbital and other orbital, say EG star orbital. Let me label these orbitals by black ink. It is our T2G orbital and here EG asterisk orbital. And this energy gap as per our sigma bonding interaction is delta O. This is the energy level present in the sigma bonded metal ligand complexes. Is this point clear?
Yes, sir.
Sir.
Yes, sir.
Okay. Now come to the ligand orbitals. We conclude energy for ligand orbital is low or high?
Low.
Low. So I represent here T2G orbital from the ligand. Now here interaction overlap has to occur between whom? The T2G set from metal and T2G set from the ligand. How will they interact? If three orbitals are there, then those three orbitals from other will interact to produce one set as a bonding and other set as antibonding. Bonding orbital energy will decrease. Let me decrease the energy by say 4 lines, 1, 2, 3 and 4. By the way, for antibonding it will increase by 4 lines, 1, 2, 3 and 4. Yes, students, are you understanding what I am saying?
Yes, sir.
Yes, sir.
Yes, those orbitals I represent here. See, 1, 2, 3. It is our T2G, and of course, this will be the antibonding T2G. Let me label those orbitals. This is our T2G orbital, and it is a antibonding T2G asterisk, right? T2G star orbital. Antibonding means asterisk. Let me complete this energetics. As like the combination I have shown from metal or say from complex sigma bonding, this energy gap will be there. Accordingly, from the ligand, this energy gap. So here, that's a combination between T2G set from metal ligand sigma bonding and T2G set from the pi bonding I have shown to you. Now, what about the EG star orbital? That EG star orbital now has to play no role for pi bonding. So it will remain as it is. Let me label that orbital as EG star star orbital. So whichever the orbitals were in my consideration, all orbitals are represented at this moment. My focus here is on delta O value. What was delta O value? It is an energy gap between the T2G set and EG star set. It is a sigma bonding. But now the T2G orbital has changed. T2G orbital is with the two forms. One form is this lower T2G orbital, bonding T2G orbital, and other form is higher T2G orbital. That's an anti-bonding T2G orbital, T2G star orbital. Out of those two forms, which form shall I consider now in order to define the delta O? It is a question. Now think on these energies of T2G and T2G star. It is our previous T2G orbital energy level. I am with the two options here. One option, lower T2G orbital, and other option, higher T2G orbital. First option and second option. You can answer my question. Out of these two options, which option is near to previous T2G, near to energy of previous T2G? First option or second option? No, I'm not understanding what is the problem. Where is the problem?
Second.
I want further two answers.
Question not clear, sir. Repeat.
Okay. I am here with two kinds of T2G orbital. It is a first T2G orbital and it is a T2G star, second T2G kind of the orbital. Out of these two, 1 and 2, who is near to this T2G orbital? First T2G set or second T2G set? Who is near?
Second.
One more answer I want. Yes, where is the problem? Why can't you answer? Is it too difficult? See, I repeat the concept. Pay proper attention now. From this T2G, I am decreasing it by 3 lines. 4 lines. 3 and 4. Similarly, from previous T2G, I am increasing it by 1, 2, 3 and 4 lines. So T2G star is raised by 4 lines compared to whom? Previous sigma bonded T2G orbital. 4 lines, keep in mind. Other way, from that T2G orbital, lower orbital, that's a bonding orbital, is low by 1, 2, 3, 4, 5 and 6 lines. Remember, 6 lines. T2G orbital lower by 6 line compared to previous T2G orbital. Similarly, this anti-bonding orbital is higher or raised from that ligand group orbitals by 1 line, 2 line, 3 line, 4 line, 5 line and 6 line. Remember this number, 6. So what I am finding, this lower T2G orbital, bonding T2G orbital is low in energy compared to important metal ligand sigma bonded T2G orbital by 6 lines. And anti-bonding T2G orbital is increasing in energy by 4 lines. My question was, out of those two, T2G1 and T2G2, or T2G and T2G star, bonding or anti-bonding orbital, which orbital is near to this T2G set from metal ligand sigma bonding? Yes. Now can anyone answer? No, I'm not understanding where is the problem. Is there problem in discussion?
No, sir.
No, sir.
Then what is the answer?
No, sir.
What is the answer? First T2G or second T2G? Bonding
Second.
T2G, anti-bonding.
Second.
Yes. I want further two replies.
Second.
Last.
Second.
Okay. Okay, good. So here I need to consider this T2G set to define delta O. And AG star already is there. I can't change that. There is no change in energy level. So previously, this energy gap was delta O, this energy gap. Now, energy gap between T2G star and EG star, this energy gap will be delta O. This energy gap will be delta O. Previously, delta O was this much. Now, delta O is this much only. So, what can we say? Delta O increases or decreases here in case of the L to M kind of the pi interaction. Delta O increase or decreases?
Decreases.
Yes, decreases. It's a discussion for L to M kind of the pi interaction. Sigma interaction already was discussed. Pi interaction discussion was started last time. M to L kind of pi bonding I discussed last time. Today I discuss L to M kind of pi bonding, and here we have covered the first part of the second unit. That's a molecular orbital theory for coordination compounds. Is this today's discussion clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Answer for my question then. Which ligands I consider for L to M kind of pi bonding? Example of ligand. First.
Chlorine, bromine, fluorine.
Yes, don't say fluorine, say fluoride or fluoro. Fluorine means F or F2. Fluorine molecule means F2, fluorine atom means F. Here we are talking about ligand. F minus, Cl minus, Br minus or I minus. So halide ligand is example for L to M kind of pi bonding. Now be fast. What is the example for M to L kind of pi bonding, especially for ligand? Three diagrams I have shown to you. First diagram was for the L to M kind of pi bonding. Next two diagrams were for the M to L kind of pi bonding. Out of that, second diagram emphasizes which ligand?
Arsine,
Right, arsine or phosphine. And other type of orbitals. Third diagram was there. Where what was there? Yes, at least complete. One letter left.
carbonyl.
Yes, carbonyl or cyanide, where anti-bonding p orbitals were there, anti-bonding p orbitals, higher energy orbitals. Here, d orbitals, higher energy orbitals, and their interaction I had discussed. Yes, do you have any doubt or any question about this all? Sigma bonding, molecular orbital treatment, general molecular orbital diagram I discussed. Then particularly we applied a demo diagram for various molecules. Few molecules I discussed here and other molecules I want that you should prepare. Then I come to the pi bonding interaction, pi bonding, which are different types of the interactions. And two types I discussed, M to L and L to M kind of the pi bonding with examples with MO diagram. Any doubt about that?
No, sir.
No, sir.
No, sir.
Yes, students. Now I want to ask, if no doubt, then shall we stop now?
Yes, sir.
Yes, sir.
Okay, other students are replying in the text box. Okay, students, the recordings and all uploading is needed. Give me a few days. I'll complete that. Then assignments also will be there, right from FY to TY. The pending tasks are there for last 2 weeks. Uploading is not done. I'll do that. Some little delay is there. Sorry for that. But this week, I'll cope up with the situation. Yeah. So I want to stop the discussion today. Let me add a next point. That's a next topic, next bit from the unit number 2 about the stabilities next time. So I declare here today's session is over. Quit now. Lecture is over.